So today we're moving on into part 2 of section 6.1. Something to keep in mind, you can use a table of values, an expression, or an equation to represent a pattern that's either a picture or a sentence. Okay, so what that means is a table of values, an expression, or an equation, they're all related because what they do is they essentially describe a pattern. So we'll be using these throughout the lesson. So let's move on. Question number 1, write an equation that models the relationship between the two columns of numbers in each table. So here we have our x values, here we have our y values. Notice our x values are all increasing by 1, and our y values are all increasing by 3. Okay, so we want to come up with an equation. The skeleton of the equation is y equals something x plus something. So this is actually called the y-intercept form, but we don't really get into that until late grade 9 or grade 10. But essentially what we're doing is we're looking for a pattern here. What do you do to the x value to get the y value? So what do we do to the 1 to make it 16? What do we do to the 2 to make it 19? And if you remember from the last lesson, this value here is the y value when x equals 0. So if I look at this table of values, it's already given it to me. I don't have to backtrack and figure it out. So when x equals 0, y equals 13. Okay, so then to figure out this number here, what do I do with the x value? So what do I do with 2 to make it into 19? What do I do with the 3 to turn it into 22, knowing that I have to add 13 to it? So you would, right, spend some time thinking about it, and then it looks like I would have to multiply the x value by 3 and add 13 to get the y value. So here, if I take this 2, multiply it by 3, I get 6, and then if I add 13, I get 19. So you want to make sure that it works for, it will work for each of these values here. So y equals 3x plus 13. Let's try question B here. So this is typically our x, and this is our y. This is the independent variable on the horizontal axes. This is the dependent variable on the vertical axes. So here we're going up by 1, and over here we are going up by 7. Okay, so let's write out our equation. Y equals something x plus this number here. This is the coefficient. This is the constant. Okay, this one here as well. When x equals 0, y equals 17. So I plug that in here. And now what do I have to, I look to find the pattern. So what do I have to do to the x values to get the y values? And you can spend some time thinking about it, and it looks like I would multiply each x value by 7 and then add 17 to get the y value. So just a quick review on, we touched on this last class as well. Moving on to question number 2, create a table of values for each equation. Oh, before I move on, I wanted to go back here, and instead of using x and y, I want to use the variables that they gave me. So x is actually r and y is p. So p equals 7 times r plus 17. So r and p are both variables for an equation. Okay, question number 2, create a table of values for each equation. So now I've got the equation, I want to come up with the table of values. So I have x and y, and now typically the values we use for x are always -2, -1, 0, 1, and 2. This is fairly consistent with what we use in grade 9 and grade 10. So for our x values will always be -2, -1, 0, 1, and 2. And what does y equal? So I plug in, let's start with this one here. I substitute in the x value of -2 for x. So I have 4 plus 6, which is 10. So when x is -2 in this equation, the y value ends up being 10. Okay, then I do the same thing for the next x value. And I plug in -1. So I have -2 times -1, which is 2. And I add it to 6, so I get 8. Okay, and so forth. So you would plug in 0 into the equation, you would get 6. You would plug 1 into the equation, you would get 4. And then you would plug 2 into the equation, and you would get 2. So I'd like you to pause the video and try the example B. Actually, no, I'm going to go over this example with you guys as well. So in example B, same thing. I want to create a table of values. And the x values that we always use are -2, -1, 0, 1, and 2. And now I'm going to plug those x values in to determine my y value. But if you look here, you'll notice that this equation does not have y by itself. So I have to manipulate the equation to do that first. So I'm going to add y to both sides so that I have 2x equals 5 plus y. And then I want to get the y by itself, so I will subtract 5. Okay, so I have this equation, y equals 2x minus 5. And now I will go and plug in these x values here into the equation and solve for y. So the first one, I plug in -2. So I have -4 minus 5, which is -9. Okay, then I plug in -1. So -2 minus 5, which is -7. Okay, and so forth. So when I plug 0 into this equation here, when I plug 0 in for x, I get -5. When I plug 1 in for x, I get -3. And then when I plug in 2, I get -1. And you know you've done it correctly if you are going up or down by the same number. So here it looks like I am going up by 2 each time. Right, so you can always double check. It should be linear. Okay, and then in section 6.2 we're going to get into graphing these on a coordinate grid. So I just wanted to introduce that today. And now example 3, I've got a written pattern here, and I want to come up with a table of values, an equation, etc. So Amrit creates a number pattern that starts with -7. Each number that follows is 4 less than the previous number. So in part A, we're being asked to make a table of values. Okay, so I know that my first number is -7. Okay, what's my second number? It says each number that follows is 4 less. So what's 4 less than -7? So you're subtracting 4. Okay, my third number will be 4 less than that, so -15. My fourth number is going to be -19, and my fifth number is -23. So there's my table of values for the first 5 numbers. In part B, we want to come up with an equation. So we use that y-intercept equation. So y equals something, x plus something. And I always start with this here. This is the y value when x equals 0. So I go back up here. I need to figure out what the y value is when x equals 0. So when x equals 0, I was adding 4. Sorry, I was subtracting 4. So if I go backwards, I would add 4 to that, which would give me -3. So I know that my y value is -3, and then I need to think about how do these x values become these y values. So what's the pattern, right? So you spend some time thinking about it, and how does 3 turn into -15, knowing that I have to subtract 3? How does 4 turn into -19, knowing that I have to subtract 3? And it looks like you have to multiply each x value by -4 and then subtract 3. So for example, if x is 3, 3 times -4 is 12, and then take away 3 would be -15. So here's my equation. Y equals -4x minus 3. And for part C, what is the value of the 40th number? Okay, so the 40th number, that would be the x value. So I plug in 40 for the x value, and I get -160 minus 3, which is -163. So I can say that the 40th number has a value of -163. So y equals -163. And then last question here, part D, which number in the sequence has a value of -203? So now we're looking for the x value. This is what we plug in for y. So we plug in -203 for y. And we need to solve for x. So we add 3 to both sides so that we have -200 equals -4x, and then divide both sides by -4, and x equals 50. So the 50th number has a value of -203. So that's it for this lesson. You can start the workbook questions.